Hey everyone, so I'm not in class today, but you still have things to do. You'll be working on this asynchronous activity I have for you today. And to help you out, I've even kindly recorded the lecture because I know you would be heartbroken if you missed a lecture with me. So this is our Intro to Ionic Compounds, our first bit of notes for Unit 3. So let's set the stage a little bit before we jump into the new stuff. We already know that there are these things called atoms made up of protons, neutrons, and electrons. We already know that protons have a positive charge and electrons have a negative charge. We already know that the electrons have to go in a set of discrete orbitals. That the first orbital can only fit 2, the second can fit 8, the third can fit 8, and so on. We already know that an atom wants that outside shell, that valence shell, to be full. So to get full, it's going to become an ion, either by losing the few that it has on the outside, leaving the full one inside, or by stealing a few extra electrons to fill it up. Doing this makes it become an ion. But when it's an ion, it gets an electric charge, just like static electricity. Like when you take a balloon and you rub it on your head and now the balloon sticks to your hair, that's because they have an electric charge, just like ions do. Now, here's the thing though. Just like your hair sticks to the balloon, positive ions stick to negative ions. When they do that, when a positive thing sticks to a negative thing, it's called an ionic compound. So specifically, an ionic compound is when you got positives and negatives sticking together in such a way that the overall charge is 0. So if I got a positive 1 and a negative 1 and they stick together, that's a compound. If I have a positive 2 and a negative 1 and they stick together, that's not a compound. If I have a positive 2, a negative 1, and then a different negative 1, and all three stick together, that is a compound. So my favorite example of an ionic compound is table salt. This is a close-up picture of what table salt looks like. If you look at it under a microscope, you see that salt makes these perfectly cubic shapes. Really cool. And the reason why is because it's made out of sodium chloride. Sodium's a positive 1 charge. Chlorine is a negative 1 charge. So you only need 1 and 1 to click together to make it neutral, to make it a compound. But what actually happens is when you get a bunch of them together, they stack on top of each other, like in the picture, making these perfect cubes at the atomic level. Now, there's also this thing called the ionic bond. The ionic bond is literally when the positive and the negative stick together. When you have an ionic bond, they make an ionic compound. When you have an ionic bond, there's the ionic bond, a positive and negative sticking together. They make an ionic compound. Notice that I have a +1. Sorry, that's a typo. It should be a +2 on that magnesium. So you got a +2 and then a -1 and a -1 to make a total charge of 0. So we have names for everything in chemistry. Ionic compounds is when you have positives and negatives together such that the total charge is 0, like Mg2+ and Cl1- with another Cl1-. But we have names for these things because we need even more names than just calling it an ionic compound and ionic bonds. We now have a new name for positive ions. We're going to call them cations. Negative ions are now going to be called anions. And here's a pretty picture to help you remember the difference. The cation has a positive charge. Oh, that's so cute and disgusting at the same time. But guaranteed, you're not going to forget now. So an ionic compound is when you have cations and anions stuck together so that the total charge is 0. Like Mg2+, remember that's a typo, it should be 2+. When the Mg2+ and the Cl1- stick together, that's a bond. So it has one bond over here and it has another bond over here. But the whole thing together that has a total charge of 0 is called an ionic compound. Now, we can represent this ionic compound with either a chemical formula or a name. The chemical formula in this case is going to be MgCl2 because I have one Mg and I got two Cls. So our chemical formula is just a list of all of the atoms, all the elements that we got, and then telling us how many of each we have. Notice it doesn't say Mg1Cl2, it's just MgCl2. We don't ever have to write the 1. All right, now we could classify this with just the formula, or we could also use the name. And as previously stated, chemists name everything. So here are the rules for naming an ionic compound. MgCl2, you're going to take the cation name, which is magnesium. You're going to take the anion name, which is chlorine, and then you're going to change the end of it from chlorine to chloride. And that is the name of our ionic compound. All right, clear as mud, I know. But this is enough to get you started on today's activity. For today's activity, you are going to 1, open Google Classroom. 2, you're going to find the Making Ionic Compounds assignment. You're going to open up the attached drawing and read the instructions. You're going to watch both linked videos. They are linked in the drawing itself. Once you've watched both those videos made by Mr. Kosteka, you are then going to fill out the table in the drawing with all of the possible combinations. When you're done with that, you're going to answer the conclusion questions that you can find in the instructions. Just on a piece of paper is fine. Take a picture of it, hand it in, and you're good. That is today's assignment. That is today's assignment. All right, I'm not checking my email during the day, but I will after school, so you can always shoot me an email after school if you have a question. But the key thing here is that you do what you can. Do your best, and don't worry about anything else. And I'll see you next week. For some of you, in person.